Today we're going to talk about contingency tables. A contingency table allows us to look at two categorical variables together. It shows how individuals are distributed along each variable contingent on the value of the other variable. Example, we can examine the class of ticket and whether a person survived the Titanic. The columns are by class and the rows are by whether they survived or not on the Titanic. The margins of the table, both on the right and on the bottom, give totals and the frequency distributions for each of the variables. Each frequency distribution is called a marginal distribution of its respective variable. The marginal distribution of survival is 711 over 2201 and 1490 over 2201. Each cell of the table gives the count for a combination of values of the two variables. For example, the second cell in the crew column tells us that 673 crew members died when the Titanic sunk. A conditional distribution shows the distribution of one variable for just the individuals who satisfy some condition on another variable. The following is the conditional distribution of ticket class conditional on having survived. The following is the conditional distribution of ticket class conditional on having perished. The conditional distributions tell us that there is a difference in class for those who survived and those who perished. This is better shown with pie charts of the two distributions. We see that the distribution of class for the survivors is different from that of the non-survivors. This leads us to believe that class and survival are associated, that they are not independent. The variables would be considered independent when the distribution of one variable in a contingency table is the same for all categories of the other variable. A segmented bar chart displays the same information as a pie chart, but in the form of bars instead of circles. Here's the segmented bar chart for ticket class by survival status. Let's take an example. A company held a blood pressure screening clinic for its employees. The results are summarized in the table below by age group and blood pressure level. Find the marginal distribution of the blood pressure levels. So what we're looking for is the totals for each row and then the percentages from that. So for the low, we have a row total of 96 and there's 480 grand total, so 96 over 480 gives us 20%. For normal, there are 230 in that row, so 230 over 480 gives us a 48%. And high is 154, that is the total of these numbers right here, over 480, which gives us 32%. Find the conditional distribution of blood pressure level for employees under 30. So what we're looking for is the blood pressure given that they're under 30. So for the low, we have 27 that are both low and under 30 over 98, which is the total for the under 30. So 27 over 98 gives us 28%. The distribution of normal, given that they're under 30, is 48 over 98, which gives us 49%. And finally, the high, given that they're under 30, is 23 over 98, which is 23%. So here is a segmented bar chart of what we've just done. Notice that the total has to add up to 100%. So we have the low down here, which is 28%. We have normal, which is another 49% to get us a total of 77%. And then we add up the high, and we add that on, and we get 100%. The next thing we're going to talk about is called Simpson's paradox. When looking at statistical scores of groups, these scores may change depending on whether the groups are looked at one by one or if they are combined into a larger group. Take an example. Suppose two people, Ann and Bob, edit articles for a newspaper. On the first day, Ann edits 100 articles, improving 60 of them, while Bob edits just 10 articles, improving 9 of them. So create a little table here so day 1, Ann improved 60 articles out of a total of 100, so the percent improved was 60%. Bob improved 9 of them out of 10, giving us 90%. On the second day, Ann edits 10 articles, improving 1 of them, while Bob edits 100 articles, improving 30 of them. So here on day 2, Ann improved 10% of the articles she worked on, while Bob improved 30% of them. So in both days, Bob did better than Ann. Now, when the 2 tests are added together, both edited 110 articles. So Ann, who did 60 on the first day and 1 on the second day, has a total of 61 that she improved out of 110. So her percent improvement is 55%. Bob, who improved 9 the first day and 30 the second day, giving us 39 out of 110, and he improved 35% of the articles. So when we combine the 2 scores, we can see that Ann did better than Bob. So who really did better in terms of improving the articles, Bob or Ann?